Let me pull them apart. I'll release it. So they're released from rest. So now how much this got elongated? This end got shifted by x1. This end got shifted by x2. I'll release it. Then how much of spring force will act? Kx, not kx1. Elongation of the springs at the displacement of both the ends will be different. But what is the elongation? X1 plus x2 is elongation. I think you cannot write kx1, kx2. Am I right? It should be kx and kx only. Because the same spring force will act at both ends, but the displacement of blocks, let it be different here. Now I release it. So after releasing, the blocks, so when they come to the initial natural length, here there's no elongation. This one, the spring is relaxed. What is the state of the blocks? They will have velocities v1 and v2. Then what will happen? They'll undergo compression. I'll show a few diagrams so that you'll understand. Okay, here maximum compression. So at maximum compression, Kxm will act. Again, they'll come back to the mean position, where they will have velocity now like this. Like this, what happened? They'll be executing SM. So this is the mean position. Okay, this is the right extreme. There's a mean. Okay, let me do one thing. Okay, this is the, don't say right extreme, left extreme. So this, if you say this is t equal to 0, this will be t equal to t by 4, t equal to t by 2, and this will be t equal to 3t by 4. Then again, when they come back to same position, so this will be again, okay, I have a diagram, no? I'll directly replace this, yeah. See, a student has to do all this imagination. It's very important. Huh? It's not like some diagram, I'll draw it, okay, problem solved. Okay, this is the T. Like this, what happened, the block, this is one oscillation. Huh? We have to calculate this time period. Okay, how is the displacement for the blocks are given? Towards left. Then how the spring force will act? Towards right. So therefore, shall we proceed now into the calculation part? Minus MA minus M1A equal to Kx minus M1A1, sorry. So let the acceleration of the block be A1. Let the acceleration of this block be A2. But X is not displacement of block, no. X is what? Elongation of spring. What is the displacement of block? X1, X2 are displacement of blocks. Try to see. X is what? Elongation of the spring. So therefore, what is the SHM? Acceleration of the block should be proportional to negative of its displacement. So I should replace X in terms of X1. Anybody's help, you can take it. We know X is equal to X1 plus X2. And from center of mass concept, M1 X1 equal to M2 X2. From where I'm writing, center of mass will not shift, no? So what is this? This is the position of center of mass. It will never shift. Though the blocks are oscillating, center of mass will not shift. Star mark, what is the star mark? Star mark is what? Center of mass of system. Fine. Okay, let me replace now X in terms of X1. So let me replace X2. So this will become X equal to X1. X2 will be M1 X1 by M2. So M1 equal to M2X by M1 plus M2. Okay, X only I needed, no? X is equal to M1 plus M2 X1 by M2. Let me replace this in this equation. What do we get? Minus M1A1 K m1 plus m2 x1 by m2. I think now I arrived at equation minus k by m1 plus m2 by m1 m2 into x1. So this everything is what I'll write mu. Mu is called as reduced mass here. So what is the time period? Okay, what is the mu? 1 by mu equal to 1 by m1 plus 1 by m2, where this mu is called as reduced mass of system. So what is the time period of oscillation? T equal to 2 pi mu by k. Okay, see now. Suppose say, what is the idea, sir? Why you are calling reduced mass? Okay, the method is very simple. You need not to think very big here. So what is the mass of system? Suppose say m1 equal 2 kg, m2 equal 3 kg. So what usually we write it? So let's take some example itself. 6 Newton per meter. Okay, what is the mass of system? I think everyone will say, sir, 5 kg. But in the expression for time period, what you get? In the expression for time period, it will be 2 pi. First, we'll calculate what is reduced mass. 1 by mu is equal to 1 by 2 plus 1 by 3. I think this will be 6 by 5. 6 by 5, 1.5 kg, the value of mu. Then what should be the answer? 1.5 by 6. This will be 1 by 4 or pi seconds. This will be, sir, we are not understanding still. What is the mass of system? 5 kg. But what I should substitute? T equal 2 pi total mass of system. M by K total mass should be 5 by 6. Okay, this is 3 by 2. 3 by 2, 2 pi is, oh, here I'm missing. I'll make correction. Yeah. Oh. I'll get the screen. Saved or not. Oh, I think I lost it. Let me save it. 2 kg block, 3 kg block, K equal to 6 Newton per meter. Okay, this 2 pi is there, no? So I'll write. Okay, what is the value of mu? So mu is equal to 1 by mu is equal to 1 by 2 plus 1 by 3. So mu is equal to how much? 1.5 kg. Then time period T equal to 2 pi mu by K. Substituting this, I'll get pi seconds. So what is actually, what is the meaning of reduced mass? See, that's what we have to just understand. Nothing bigger, there's nothing you know to bother anything that one. What is the total mass of system? We just say, okay, they are 5 kg. Will I substitute 5 kg? No. When they're oscillating, effective mass of system has to be produced. And that effective mass is less than the total mass of system. That's all I call reduced mass of system. That's all. Beyond this, you need not to bother anything at your level. You need not to bother anything very big. Sir, what is reduced mass? What is the concept? This is what concept. What is the total mass? What is the net mass as seen by the spring? The spring will see that the mass is 2 plus 3, not 5. In fact, it is 1.5 kg. The spring will feel, no, not ourselves. The spring will feel. I'm making things clear. That's why it is called like a reduced mass of system. It's having huge applications at higher level. At our level, just it's a formula. Got the idea? So there's not 5 kg. You should not write 5 kg here. It should be effective mass of the system has to be substituted. Sir, I will not agree. You do one thing. Let me make this infinite mass. If this is infinite, then 1 by infinity. Then what is mu? Mu will become equal to this mass only. I think that's what spring block system earlier what we did. 1.2. 1.2. Okay, later. So if it is 1.2, I think things will change. Zero point 0.2, so 2 pi. Let me keep here. So this is a time period. Okay, agreed. This is the thing. Now you see the one. Let this wall, this 2 kg, let this be infinite mass. Infinite mass, it cannot move. Then put infinity here. Then what is the time period? The same, it was like a m by k only. If wall is also is moving and it's having a finite mass, then effective mass will come into picture. Okay, the center of mass will not shift. All the basic ideas already in center of mass, we have discussed this problem. If you can recollect, what is the maximum speed? Then what is x? X is the displacement what we have given. X is what initial elongation of the spring is given and they are released from rest. Let me take the next question.